All right, we're working with the North Carolina released EOC questions, and we're going to start with the Polygon and Circle review questions. If you have the packet from Mrs. Overman, this is page 1. And I'm going to do them in order. If you have the key, this is like the first answer. So JK and LM are perpendicular diameters of a circle. They are each 12 inches long. What is the approximate length of chord LK? So this is what we're looking for right here. So the first thing I'm going to do is go ahead and draw a pretty bad circle. There we go. And I'm going to make a diameter, JK. So the point J and the point K. Then I'm making another diameter that's perpendicular. So that means it's going to cut it kind of in quarters. There's L and there's M. And one thing I know about the diameters is that each is 12 inches long. D equals 12. All right, D equals 12. So that means that the radius, the distance from the center to the edge, is 6. And that's 6, and that's 6, and that's 6. The question asks for the length of chord LK. Since these are perpendicular, this makes a right triangle. So you can draw, I like to draw it separately, 6, 6, and I'm looking for this. There are two ways to solve this. If you remember your 1, 1 square root of 2 triangle, you could use a proportion and solve it that way. And that's actually a really fast way. To get from here to here, I have to multiply by 6. Here to here, I have to multiply by 6. So from here to here, I have to multiply by 6. My answer actually is 6 square root of 2. But let's say you're not very comfortable with those triangles. And what's the other way you could find this? Well, you could just do Pythagorean Theorem. 6 squared plus 6 squared equals x squared. 36 plus 36 equals x squared. 72 equals x squared. Believe it or not, then I'll say x equals square root of 72. Oops, running out of room. So those two things are the same. And when I get my calculator and substitute them in, here we go, clear, clear. So getting my calculator, I'm going to go square root of 72, second, and then the x squared button, 72. So it looks like this, enter, and I get 8.48, which is answer D. By the way, if I had done 6 second square root of 2, guess what I get? Exactly the same thing. So when we round this to the tenths, that's 8.5. All right, the next problem is, what is the measure of an interior angle of a regular polygon with 16 sides? Now, a lot of people are tempted to say, oh, I need to divide 360 degrees by 16 to find this. So a lot of people go, oh, let me do that. But really, this is not a quadrilateral. This is a 16agon. All right, which means it has n minus 2 times 180 degrees. This formula is not on your math chart. Memorize this. What this gives is total number of degrees. Okay? So what we're going to do is we're going to apply this formula for this problem. And we're going to go 16 minus 2 times 180, 14 times 180, which is 2,520. So that's the total number of degrees, but I want, if it's a regular polygon, that means it has equal angles. How many angles does it have? There are 16 angles. So I take 2,520 divided by 16, and I get 157.5. So the correct answer is C. Next problem, going up to the top of the page. If WYZ is a parallelogram and measure of angle W equals 40, what is the measure of angle Z? The secret to this problem is to go ahead and draw out the parallelogram. So I'm going to go ahead and pick the acute angle to be the 40 degrees, so that's W. The other secret is to go in order, W, X, Y, and Z. Go around the parallelogram. Do not go W, X, Y, Z. The order, you can go clockwise. Even if I went this way, it would still work. So the question is, what is this angle right here for Z? Well, for a parallelogram, these two angles are supplementary. So that means that they have to add up to 180. So I can subtract 40 from both sides, and I get the measure of angle Z equals 140 degrees. Answer C. Now they want to know on the next problem which statement is logically equivalent to the given statement. If a quadrilateral is a rhombus, then it is a parallelogram. So let me go ahead and, if I remember my parallelogram Venn diagram, then I have parallelograms, and then remember we had rectangles and rhombus. Rhombus was over here and squares were over here. I'll do rhombus, RH for rhombus, rectangle, and then squares in there. And all of these are parallelograms. You can see that I could be in the parallelogram part, but not necessarily, well, if I'm in the rhombus part, then I'm definitely a parallelogram. So this statement is always true. If I'm in here, then I'm in the parallelograms. Now the question is, if a quadrilateral is a parallelogram, then it is a rhombus. Is it possible to be in the parallelogram area but not be in the rhombus area? Sure, you can be anywhere outside of it. Anywhere out here, even in the rectangle area, would make this statement false. If a quadrilateral is not a rhombus, then it is a parallelogram. Well, there's actually another group, even bigger. Parallelograms belong to quadrilaterals. And you could have just quadrilaterals that are not any special category. You can have trapezoids. You can have kites. And these, just because a quadrilateral is not a rhombus, doesn't mean that it has to be one of these. It could be a rectangle. So if a quadrilateral is not a rhombus, it could still be a parallelogram. So this is false. Now, if it was one of these, I would make it true. But the thing is, I'm trying to see if I can make this false. If a quadrilateral is not a rhombus, then it is a parallelogram. So that's where this Venn diagram comes in handy. Can I have something that is not a rhombus, but makes this false? Makes it is a parallelogram false. And yeah, if it was a kite, that's a quadrilateral that's not a rhombus, and it's not a parallelogram. If a quadrilateral is not a parallelogram, then it is not a rhombus. Well, I could have something that's out here that's not a parallelogram, and you can see if it's outside of the parallelogram circle, it cannot be a rhombus. So this statement is true. So D is your answer.